Last type of problem that we're going to look at is more multiplication, and then we'll also have the simplifying to deal with along the way. We'll really save division for tomorrow. Example 3 here. We want to simplify. And we'll just do square roots this time. The square root of 45 x to the 5th y cubed times the square root of 35 x y to the 4th. Now we have a couple different ways to do this. We can either simplify now or simplify later. I usually like to simplify earlier on just because then I would have smaller numbers to work with. We could, kind of as you saw before, multiply our radicands together and then simplify our whole square root at the end. But then I'd have to simplify whatever 45 times 35 is, and I think it's a little bit easier to simplify before, if at all possible. So I'm going to simplify now. In the B example, I'll show you what it would be like to multiply first and then simplify at the end. But right now, simplify each individual radical, what we can. The square root of 45, x to the 5th y cubed. Well, think about perfect squares, since we have the square root. 45 is 9 times 5. And then if I have this x to the 5th underneath, well, that's x squared times x squared times another x. And our y cubed is y squared times y. Simplifying this whole radical, take the square root of the 9. I have my x squared here, my x squared here, my y squared here. I can take the square root of each of these and get x squared y times the square root of 5xy. I'm going to leave this for now, and then at the very end, think about where my absolute value is going to be needed, if at all. Then I have the square root of 35xy to the 4th here. Is there any perfect square that goes into 35? No. So we're stuck there. The only thing we really can simplify here is that y to the 4th. Take a y squared out. You'd still have 35x underneath the radical. This is a little bit nicer than what it is before. I still have to take that 5 times 35, but not terrible. To multiply our radicals like this, our radical expressions, multiply what's out front, and that gives me 3x squared y cubed and then we'll also multiply what is underneath our radical. So let's see, I'll have to take 5 times 35, which is 175. And then I'd have an x here, x squared, y. And sometimes, like you see here, after we do that multiplication, we'll actually be able to simplify a little bit more than we could have before. And again, that's what we see here. So 175, what perfect squares go into that? That's 25 times 7. We can square root our x squared also. The square root of 25 is 5. That's going to come out front. And let's multiply that with the 3 that's already there, giving us 15. We said we could square root this x squared also, which would be x. We already have an x squared, which gives us x cubed total. The y cubed we already have there. Times the square root of We have the 7 underneath still, and also our y. Okay, we're almost there. Now, the last thing we have to think about, since we had a square root here, is if absolute value is necessary. So again, whatever comes outside our square root really should have an absolute value around it. Now let's think about, do we actually need it or not? Well, the 15, we won't need it there because that's always going to be positive. Then our x cubed, could that be negative? Well, since it's to an odd power, a negative number to an odd power could be negative, which means that we would usually need absolute value. But one other thing to look at is back in your original problem, specifically this little part over here, the square root of 35x, y to the 4th. If my x value is negative, even if y was negative, because y is to a 4th power, y is to an even power, if x is negative, we'd have the square root of a negative number. And again, remember this chapter, we're sticking with real numbers. So we can't have that. Since x really has to be a positive number, x cubed is going to be a positive number. So we don't really need the absolute value there either. As I mentioned in yesterday's videos too, this absolute value part is really the hardest part of the whole chapter, just figuring out whatever works for you in terms of reasoning and remembering when you actually need the absolute value or not. Last little part, let's look at our y cubed here. Since it's to an odd power, typically we would need our absolute value around it. Well, let's look here. If I look at the square root 35x y to the 4th that I'd seen before, it would be okay if y is negative there because it's to a 4th power. But if I look at my other radical, I'd have y to the 3rd. If y was negative, then we'd have an issue there. So since y also has to be positive, we really don't need absolute value in any of these places. And my final answer would be 15x cubed y cubed times the square root of 7y. This is pretty hefty stuff.